Okay, so this is a knotted sphere in 4 dimensions, and it's embedded into 3 dimensions, or no, it's projected into 3 dimensions. And so what that means is, if we were to stand high up in the 4th dimension and look down, we'd get a 3-dimensional projection, and this is what it would look like. So the top face of the cylinder is kind of being pinched into its own body and pulled down. So we get this thing in here, and the side of its body is actually being pulled outwards as well. And down here, this whole tube which is being pulled from the top face of this cylinder actually crosses itself at the bottom. So there's a crossing here, and it crosses under the face or over, depending on what kind of crossing it is. And it comes down here, it comes all the way over here, and then there's another crossing here, another crossing here with this tube. It goes inside of it, and there's all sorts of weird knottings going on. It's all tangled within itself. So before we move on, I guess we'll talk about lower dimensional stuff, just so we can get a better intuition about what's going on here. So if we go over here to this thing, this is something we recognize. It's just a closed loop, and you can grab it by the sides and twist it once, and this is what you get. It's called an unknot with a Reidemeister 1, where that just means we just twist it. And if we go high up in the 3rd dimension, or in the Z axis, and then look straight down, we get a 2-dimensional projection. And this here is what it would look like. So we've projected a 3-dimensional object into 2 dimensions here. And notice that we can't, we don't know which strand here goes over the other, because there's a double point here in the middle. So we don't know if this strand going here to there goes over, or this one over here is over the other one. So what we can do is create a broken diagram where we delete some of the strand that goes under. So now we know this strand here that we can see all of goes over the other strand, this one over here, which goes on the bottom, and it matches up with our fully 3-dimensional design or figure over here. And so here are a couple ways of turning 3 dimensions into 2 dimensions. But if we want to see the full loop and not delete any of it, like this broken diagram, then what we can do is come over here and introduce a color spectrum. So we're going to turn the Z-axis, this vertical axis, into a rainbow. And so, as you can see, everything here in green is at Z equals 0, the Z plane, Z equals 0. And as we go higher up, it gets more red. So what we can do is we can literally project with this light at the bottom here, project it onto this clear piece of paper, and we get this thing over here, which is the same projection as before, and we can see everything, but now there's color to it. And since there's color, we can clearly see which strand goes over the other one, because this one's red. It's higher up in the Z dimension, or the 3rd dimension. So that means it goes over this strand over here. And so this is 3 dimensions of information condensed into two-dimensional space. And so over here, what we have is the projection, which is the same as all the way back here, what we have here where we projected 3 dimensions into 2 dimensions. Over here we've projected 4 dimensions into 3 dimensions. And notice that at each of the crossings, we don't know which one goes over the other. It just looks like they're intersecting each other. And so here is a broken diagram. Hold on a second. So here is a broken diagram of the same knotted surface. So this top part here is still being pulled down. There's no crossing there. But over here, we've deleted a little bit of the bottom face. There's still a little bit of it inside as well. And so we know now that this tube in the middle crosses over this bottom face. So this tube is higher up over here near the middle. It's higher up in the w-axis, or the 4th dimension, than the face here. And over here the face is higher up in the 4th dimension than the tube. So this tube here goes under, while the face goes over. Just like how we had a strand going over another strand, the face of this tube, or this middle tube, goes over this smaller tube here. And there's a similar thing going here. The face of this tube goes over, the face of this big tube goes over this middle tube in the middle. And we're actually pinching out a little bit of the face of this big tube. And it's going inside of it, so there's even more weird knotting going on here. And again, this is 3 dimensions. And if we want to have 4 full dimensions, we can use the colors again. So here we can clearly see that the tube is getting more red. So it's passing over the bottom face of this big cylinder. So it's not actually intersecting itself, even though it looks like it to us. But if you were able to see 4 dimensions, then you would see that the tube is actually going over the face somehow. And a similar thing is happening here with this tube and these faces over here. So here's one more look at it. Yeah, 4 dimensions.